So today we are going to talk more about exponents and we're going to discuss some rational expression problems. So let's start with this. This is a review from last week. We have this expression squared. And so the instructions on this will say to simplify. So what do I do here? So there's a lot of properties that we're going to apply that we talked about in last week's video in this week's. So I'm going to say this 2 applies to everything in here. So I'm going to say this is m. So let's point out where the 2 is going to go. It's going to go into 3 things. So this will be m squared. And then I will have the 7 squared. And then I will have b to the 5th squared. So the 2, using the properties we talked about last week, applies to everything. And then now I'm going to simplify. The numerator will just be m squared. And then I've got 7 squared, so that's 49. And then b to the 5th squared, this is a power raised to a power. So when we have a power raised to a power, we multiply the exponents. So 5 times 2 is 10. And so this would be the simplified version. We also want to look at some problems in this week's discussion that use some of these properties. For example, here's one. And so when I see these type of problems, what I like to do is I like to say, let's kind of focus on, these are, if we look at this is x to the 5th times z squared divided by x squared over z to the 8th. So with the multiplication of the 2 variables here, what I can do is I can take a look at the x's and then I can take a look at the z's. And so the x's here, this property we talked about last week, this is like bases. They are divided. It's the division of like bases. So what I do is I rewrite the x, and then I take the numerator exponent and I subtract the denominator. So that takes care of the x's. Then I'll look at the z's, and I'll do the same thing. This is z squared, and I'm going to rewrite the base of z, and then I'm going to take the numerator exponent and subtract the denominator. So I'm going to end up with x cubed and then times z to the negative 6. But I don't want to leave negative exponents. So I'm going to take it a step further. And I'm going to say z to the 6th. Well, when I have a negative exponent, remember what happens to it. How do I simplify it? X cubed will stay, but z to the 6th is going to go into the opposite location. It'll go into the opposite location, and then it will become positive. So I'm going to say z to the 6th. So z to the negative 6, all I do is move it to the opposite location and make it a positive exponent. So if it starts in the numerator, you move it to the denominator. If it would have started in the denominator, the negative exponent, you move it to the numerator and make it positive. So let's take a look at some more questions with the negative exponent. Here we have 3 over 4 raised to the negative 2 power. So the first property we're going to apply is that this negative 2 applies to both the numerator and the denominator. So I'm going to rewrite this with the negative 2 applied to both. Now, just like I had said, if you have a negative exponent, the base stays the same, the exponent stays the same, except it becomes positive, and you'll locate it into the opposite location. So this is 3 to the negative second in the numerator, so I'm going to move it to the denominator and make it positive. This is 4 to the negative second. I'm going to move it to the numerator and make it 4 to the positive second. And now I can simplify these. This would be 4 times 4, or 16. 4 squared would be 16, and 3 times itself twice would be 9. So 16 over 9 is how I would simplify this one. So again, we're working with these negative exponents and the exponent properties. So when we see something like this is all multiplication. Yes, we have some dots which mean multiplication, but if you have a number touching a variable or two variables next to each other, they mean multiplication too. So what I can do here is I can take, the numbers are not raised to a power. So these numbers we can simplify by multiplying these together. So I'm going to take 3 times 4 times 5, and I'll simplify that. Then the variables, I'm going to multiply the like bases together. So these two are alike, so this will be x to the negative 4 times x to the 4th, and I'm rewriting them next to each other, the ones that are similar to each other, right, that are alike. The v doesn't have anything to combine with, so this is kind of by itself. And then I have y, and y doesn't have anything to combine with, so that's by itself also. And then I have z, and z, we got z here and z to the negative 1 here, so that will be z times z to the negative 1. All right, so let's work on simplifying now. We've got 3 times 4, well that's 12. And then 12 times 5 is 60. And then I have x to the negative 4th times x to the 4th. When you have like bases, you can rewrite the base, and then you add like bases that are multiplied, you add the exponents. So that would look like that. The v and then the y stay by itself. So I'm just kind of trying to combine. And then I have z, and there's no power here, but we know when there's no power, it's z to the first. So like bases, I can add their exponents. So just keep simplifying. The 60 is simplified. This will be x to the 0. And this also will be z to the 0. Anything raised to the z power is 1. So this will be x to the 0 will be 1. And then also z to the 0 will be 1. So now I'll have 60 times 1 times 1, which is just 60. And then the last thing here is I have y to the negative 3rd. Well, in the problems that we're going to see, we want to not have any negative exponents. So we're going to move the y to the negative 3rd to the denominator, and I'm going to make it y to the positive 3rd. So this would be the simplified version. So this problem is to simplify, and we have u to the negative 3, w to the 5th, multiplied by this expression to the negative 3rd. So I'm going to work first with this exponent. So before I do any multiplication here, we always kind of follow the order of operations. We don't want to work with this exponent. And so this exponent is going to apply to everything in here. So I'm going to rewrite even the things I'm not touching, just to kind of keep it in order. And then let's apply that negative 3 to everything we see here. So I am going to first do these power raised to a power. V to the fourth power raised to the negative third power. This is a power raised to a power, so I multiply the exponents. So this will be V to the negative 12. And then I've got this one here, I've got a power raised to a power. So this will be negative 1 times negative 3. Well, when you multiply two negatives together, you get a positive value. So we end up with a positive 3 in the denominator. Now I'm going to take and see what I can, combine. Now we have here, we're multiplying these two items together, so think of it as if it was over 1, and you're going to multiply kind of the numerators together, so this will get multiplied together, and you would multiply the denominators together, so this gets multiplied together. So I'm just gonna rewrite everything, and I'm gonna start working on combining. So the first one here, u to the negative 3, and then I have u to the negative 3 here. So I just combine them next to each other. And then I have w to the 5th power, and I have v to the negative 12. And then in the denominator, I just have w cubed. So the w's, they are like terms. And remember, I can combine like terms that are divided by saying this would be w to the 5th power minus 3. So rewrite the w, take the numerator exponent, subtract the denominator. The u's, well, this is multiplication of like bases. I will take the base, leave it the same, and then add the exponents. So I'm going to add a negative 3 to a negative 3. And then I have v to the negative 12. So let me take another minute to do this addition. So this will be negative 6. And this subtraction here will be 5 minus 3 is 2. And then now, lastly, I'm going to work on getting rid of those negative exponents. So remember, what happens is that the negative exponents move to the opposite location. So this one's going to move to the denominator, the v to the negative 12. So it's going to go down here. And it stays the same, except now it's going to be v to the positive 12. The w is the only one that's positive, so that's the only one that's going to stay up here. We've got u to the negative 6. That's going to move to the denominator and become u to the positive 6. Now, yes, I know the u was in front and the v was second, but with multiplication, it doesn't matter what order. Typically, we put them in alphabetical order, so I'll move it in front because u does come before v in the alphabet. So it will go down here, though. And then the last one with the negative exponent is the 3. And we've got 3 to the negative 3. So that also is going to go in the denominator and become positive. So this will be my answer here. One last step is I can calculate 3 to the third power. It's 3 times 3, which would be 9, times another 3 would be 27. And so this would be my answer to that problem.